So from last week when we were talking about normal curves, one of the things you had to do was find a z-score that denotes or cuts off a certain percentage or certain area. And that's what the critical value of z is. Of course, when we're doing confidence intervals, we only really deal with a couple of 95, 99, 90%. So how do I decide what value of z to use in order to get the right confidence interval? Because remember, all of z-scores, it's a number of standard deviations, and if I want to estimate a population mean or a population proportion within 90% within 90%, so I can capture 90% of all possible answers. What you're going to do is you can either use the normal curve table, and I'm going to show you do that in a minute, or even David Lane calculator, especially if you do myopic math, when they're asking you for some weird confidence levels, the calculator is a way to use it. So you asked about the critical value for a 95% confidence level. I'm going to select value from an area. This is that David Lane normal curve calculator I pointed to a couple weeks ago. Make sure you're doing a standard deviation. The mean is 0, standard deviation 1 because they're on the standard normal curve. And we want between, because we want that 95% to catch the middle 95%, right? And so what WebAssign's looking for is the absolute value of this. So you would type in 1.96. If the reason the calculator is given this, because our lower bound is the negative 1.96, our upper bound is positive 1.96. We only really care about the absolute value of that. Okay. Now, how do you do that? So, what if I want to find the confidence interval for a 99% confidence, or the critical value for a 99% confidence? Well, you change the area, remember, value from an area, change your area to 0.99 because you want the middle 95%, and you see how it's getting negative 2.576. A little bit different what the table gives us, but it's within 1,000. So it's the table's rounding. This isn't. Okay. What about if I wanted only an 80% confidence interval? Sometimes myopic math will kick that at people. So see how it's a much smaller number? Because you don't have to be as confident. You can have a little more wiggle room. Or you don't need as much wiggle room, should I say. So that was what you'd use that'd be the critical value of z for an 80% confidence interval. Okay, so pretty easy. For the normal everyday values, Dr. Stevens in that normal curve table, scroll down to the bottom of it. Here's the critical value. Here, let me get a pointer going so you can see it. At least that way I'm highlighting it. Okay, how do we do that? Here. So this table right here, critical values of confidence. Well, for a 95% confidence interval, it's 1.645. See how that agrees with the calculator? And you see how this is rounded. When I did on the calculator, it told us 2.576. Well, this is having it round a little bit for that. Now, you can find these values in the table. Dr. Stevens has them highlighted. What he does by hand, probably looking for the middle 90%, that leave 10% outside of it, 5% on either side. So make that a decimal, 0.05, and you see why the 0.05, it falls right exactly in between those. So that's why it's negative 1.645. So in that case, it's going to be right smack dab in the middle, as it always. Okay. So hope that helps. See, you can do the same thing for that one. That's another. What is it? 2.575. Sure. So 2.575 is what they're using for a 99% confidence interval. And then do they have the other one starred? Do they have let's see, it would be 1.645 we did. Negative 1.6 I think catches it perfectly for the 95%. See, there's that one. Okay, so Minitable works for these questions. David Lane works for these questions. Just make sure from here on out, if you're going to use the David Lane calculator, make sure you're dealing with z-scores. That only happens with proportions and when you know the population standard deviation. Other things, if you only know a sample standard deviation, that's going to be a t-score. And if you haven't seen that video yet, you should. Okay, so I hope that helps.